All right, folks, let's take a look at what we got here. We have two inequalities. We have less than and equal to, less than. We have one inequality here. We have a second inequality here. So what we're going to do in today's class and in today's lesson is we're going to combine the last two topics that we've been working on. We're going to combine inequalities with systems. So what we're going to be working on is systems of linear inequalities. So if you remember, an inequality is an equation, but instead of having an equal sign, we have an inequality symbol. And what this means is instead of having a line, an equation gives us a line, an inequality gives us a shaded space on our XY coordinate plane. So what we're going to do, ladies and gentlemen, is what we need to do in today's class is we need to be able to graph and demonstrate and show what is the solution to this system of inequalities. And remember, this is going to be a shaded space, and this is going to be a shaded space. So what we're going to be looking for is the double shaded space. So I'm going to write that down, and then I'm going to demonstrate what that looks like. So I'm going to say that the solution equals the double shaded space. Okay, let's figure out what that looks like. So first off, I've got an inequality that's in standard form. Well, remember, ladies and gentlemen, we don't like standard form. So we're going to change this to slope-intercept form. Minus 3y is less than or equal to 6. And then the second equation is 3x minus 4 is less than y. So let's take the first inequality and turn this into slope-intercept form. Remember, we need to make 0 and we need to make 1. So in order to make 0, I need to subtract x from both sides of the inequality. That goes away. We've got negative 3y is less than or equal to negative x plus 6. And I'm beginning to put this into slope-intercept form. This is going to begin to be my m, and this is going to begin to be my b. But we have to turn this into 1 first. So if I've got negative 3, I need to, anything divided by itself is 1. So I'm going to divide by negative 3, divide by negative 3, divide by negative 3. Negative 3 divided by negative 3 is 1. That goes away. Now, ladies and gentlemen, do you remember what happens when we divide by a negative? And that's right, all of our signs flip and all of our symbols flip. So instead of less than and equal to, we have greater than and equal to. Negative and a negative makes a positive, and this is 1/3 x. And then we have a positive and a negative, which is a negative. 6 divided by 3 is 2. So here's our first inequality. And let's take a look at this one. Well, this is interesting. We've already got y by itself. This isn't standard form. This is actually slope-intercept form. It's just written backwards. So if we turn this around, we need to put y first. We have 3x minus 4. But what symbol do we need to put here? Do we put less than? Let's think about that for a second, because what this inequality says, it says everything on the left-hand side is smaller than y. And we have to maintain that relationship. 3x minus 4 has to be smaller than y. Well, the way that we write that, once we turn everything around, is greater than, because now 3x minus 4 is smaller than y. Let's take that from a different angle. If I read from right to left, it says y is greater than 3x minus 4. Y is greater than 3x minus 4. So when you move things around with an inequality symbol, you've got to make sure to maintain the same relationship. All right, so we've got our two slope-intercept form equations. Well, let's take a look at how we can do this with our calculator. All right, so I'm going to turn this on. Y equals, now I've already typed in our equation. So 1/3 x minus 2 and 3x minus 4. But these are inequalities and these are equal signs. These are equations. How can we change this? Well, the calculator has a solution. It's not a great solution. It's a little complex. There's a couple of steps here that I need you to remember. So take a look. I'm going to use my left trackpad. Let me move this up just a little bit so you can see it. I'm going to use my left trackpad, and I'm going to move over until I'm highlighting this little line symbol. Now your calculator is going to look slightly different, but you can still highlight the line symbol. I'm going to hit enter, and what your calculator is going to start to do is going to start to do what mine does here in just a moment. You can change and you can cycle through whatever this symbol is. This symbol is a line. This is a bold line. This is a triangle pointed down. I honestly don't even know what this is. This is a dash with a circle, and then dots. What we need, ladies and gentlemen, is this symbol and this symbol. The triangles represent greater than and less than. Now specifically, I'm gonna write this down right here on our notes. This symbol right here, the triangle with the right triangle right here, pointed up, is greater than, or it's greater than and equal to. Now the calculator can't tell the difference. The calculator doesn't know the difference between greater than and greater than equal to, but you do because we're looking at it. This one is greater than and equal to. So if we use this symbol, the triangle pointed up, then we know that it's representing greater than. The other symbol with the right angle pointed down, this is less than or less than and equal to. And that's how we can graph inequalities. Oh, I'm sorry. I missed the page here. So the triangle pointed down, this is less than or less than and equal to. So let me take a look. Let's take a look at what that looks like. So I've chosen the greater than symbol, which is what we need. So that's good. So I'm going to hit enter and get out of this. And I'm going to come down here to Y2, and I'm going to do the same thing. I'm going to hit enter, and now I can cycle through, and I can cycle through the different symbols. And this one is greater than, so I'm going to choose greater than because the inequality is pointed up. So I'm going to shade up. These are being shaded up. So we're going to hit enter. Now we're going to hit graph, and we're going to see what happens. There's my first inequality, and it's graphing the boundary line, and it's shading it for us. Here comes the second line. There's the boundary line, 3x minus 4, and it's the shaded area. Now take a look at this for a moment. We've got the blue shading in here. We've got the red shading in here. But remember, the solution is the double shaded area, which means that all the points that are shaded right in here that are both blue and red to make the purple, this purple, all of these points in the purple are solutions to this system of linear inequalities. So this whole area right here is the answer to this problem. Now in today's work, what we're going to be asking you to do is check on your calculator. You can use a calculator to do this, but then we need you, and I'm going to ask you to actually graph it on a piece of paper. So I've got a couple of map pencils, and you can borrow map pencils from me in class, and we need to graph these. We need to verify that we can make it look just like the graph here. So we're going to graph, and I'll graph this one in red, and I'll circle this one in red. And this one is, what color is this? This is black. I'm going to color this in black. I thought that was blue, but I picked black anyway. All right, so let's do this one. So this has a y-intercept of -2, which is right here. And it has a slope of rise 1, run 3. 1, 1, 2, 3 is the second point. 1, 1, 2, 3. I only need a couple of points because now I can take my straight edge and I can, is this going to be a solid line or a dotted line? It's going to be a solid line because it's equal to. Solid line. And now, did I need to shade up? Is greater than up or is greater than down? Greater than is up because it's more. So all of this needs to be shaded. All right, let's do the second one. Let's do that one in black. 3x minus 4. So my y-intercept is here at -4. And this one is a rise of 3 and a run of 1. 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Now I can draw my line here. Now is this going to be dashed or solid? Dashed or solid? This is going to be a dashed line. So we got to make sure that that gets dashed. Now I've got my dashed line. Sorry. My dashed line, and this is this going to be shaded up or is it going to be shaded down? Greater than means up. So all of this up here needs to be shaded because it's going up. So all of this is shaded, and that means this is shaded. And we see the double shaded region is right in here. Now, what point in here is a solution? Just pick any point that's just really obvious that is inside this double shaded region. I'm going to ask you to do this in your work today, just to verify that you know which am I looking at, this one, this shaded region, or this shaded region here. Well, the answer, the very obvious answer that's in the double shaded region is 0, 0. So I'll put a solution of 0, 0, and this is everything that you need to do in today's class. You need to change standard form into slope-intercept form. You need to be able to graph this on a piece of paper by hand. You can verify that your graph done by hand looks like the graph in the calculator, which mine does, so I know it's correct. And then we need to find one point that is in the solution area. Any point will do as long as it's in the correct shaded space.